Hi everybody, this is Dr.T.ANTONY Santosh, Assistant Professor of Chemistry, St.Joseph's College of Arts and Science, Cuddalore. I am handling physical chemistry. Now I would like to discuss some of the topics from thermodynamics of ideal and non-ideal solutions. First I would like to discuss the topics from electrochemistry. Electrochemistry is defined as that branch of chemistry which deals with the study of the production of electricity from the energy that is released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical transformation. Actually, electrochemistry, as from the first definition, it is related with electrons and charges, and it is the branch of physical chemistry concerned with the relationship between electrical potential difference as a measurable and quantitative phenomenon and identifiable chemical change with the potential difference as an outcome of a particular chemical change or vice versa. And not only that, it is a science that deals with the relation of electricity to chemical changes and with the interconversion of chemical and electrical energy. It is related to several topics like conductance and different types of conductance and ions, movement of ions present in a solution likewise. Let us see one by one. Next, I would like to discuss what is conductance. It is usually symbolized with a symbol G. The symbol G is not an unit, it is just a symbol. So according to book it may vary. It is an expression how easily an ion flows across a membrane, either through active pumps placed in the membrane of ion channels or when specific ion channels open. The movement of ions conducts electricity through an electrolytic solution. Conductance is actually a measure of how easily those charged particles move through a solution or material. So conductivity is the conductance measured across a specified distance through a material or solution. It is measured in Siemens per centimeter. It is measured with the SI unit of Siemens per meter. Generally, it is measured with Siemens per centimeter. Conversely, the extent to which the given sample of electrolytic solution can resist the flow of electric current is called its resistance. This conductance usually measured as a reciprocal of resistance. Next, I would like to discuss about cell constant. It is related to conductance. The cell constant of a conductivity cell is the ratio of the distance between the electrodes of the cell to their surface area. The cell constant is related to a conductivity cell. When we are using a conductivity cell to measure conductance, in that there will be two electrodes. Usually a cell is a combination of two electrodes and the distance between the electrode is L and its cross sectional area is measured with A. So if I get the relationship, the ratio G is equal to L by A, that unit of length divided by unit of area is called unit of cell constant. Okay, so the L by A usually with different, in some books it is denoted with small l by small a, and in some books it is given with, as we are seeing now, L by A. So centimeter for unit of length and centimeter square for unit of area is used as the units. So here conductivity is the amount of current carried between two electrodes by a known amount of liquid. The volume between the two electrodes must be precise or exact to determine the amount of current carried between them. This volume is known as cell constant. I think you are clear with the topic of cell constant. Next, I would like to explain what is equivalent conductance. The name itself gives us the meaning what is equivalent conductance. We know what is conductance and what speciality is equivalent conductance, that now we are going to see. Equivalent conductance is denoted with a symbol capital lambda, which is shown in the title. The equivalent conductance of an electrolyte is defined as the conductance of a volume of solution containing one equivalent weight of dissolved substance when placed between two parallel electrodes 1 centimeter apart and large enough to contain between them all of the solution. It has another definition. It is defined as the conducting power of all the ions produced by 1 gram equivalent of the substance. That is a simpler definition. And when you see that as a mathematical formula, here we have capital lambda is equal to kappa into phi. You could see that in the second point. Lambda is equal to kappa into phi, where kappa is equal to specific conductance. Kappa is nothing but a symbol, a Greek symbol, which looks like K. Okay, so what is specific conductance, that we will see in the next coming slides. And what is phi? Phi is the volume of the solution. Okay, next point, lambda is equal to kappa into 1000 C, where equivalent conductance in, that is what lambda, equivalent conductance, kappa is equal to specific conductance, C is equal to concentration of 1 gram equivalent in molar conductivity. Okay, so we could see that in different definitions we could see. So here at last I have given you the SI unit of equivalent conductance, that is Siemens meter square gram equivalent power minus 1, or per equivalent, Siemens meter square gram per equivalent. Likewise also we can say. Okay, next I would like to explain you what is molar conductance. It is a continuation of equivalent conductance and it is denoted with a symbol of capital lambda subscript m. Okay, so I would like to give you a simpler definition of molar conductance first. The molar conductance is defined as the conducting power of all the ions produced by 1 gram mole of an electrolyte. Okay, so this is one of the definitions. I would like to give you other definitions. The molar conductance of a solution is defined as the conductance of all the ions produced by ionization of 1 gram mole of an electrolyte when present in V ml of solution. It is denoted by capital lambda m. Therefore, molar conductance capital lambda m is equal to kappa into V. So it can also be defined in other manners. That is, molar conductivity is the conductance property of a solution containing 1 mole of the electrolyte, or it is a function of the ionic strength of a solution or the concentration of the salt. It is therefore not a constant value. It is not a constant value. Okay. The molar conductivity of an electrolyte solution is defined as its conductivity divided by its molar concentration. This is another formula like definition. Capital lambda m is equal to kappa by C. You know what is kappa? Kappa is equal to specific conductance. Kappa is specific conductance, where C is the molar concentration. Okay, I think now you are familiar with what is molar conductance. The molar conductance can be measured with the unit of Siemens meter square mole inverse, which is given at last in this slide. Now let us move on to the next topic, which is specific conductance. So specific, the word specific means there is something particular, there is something clear. Okay, the specific conductance is the ability of a substance to conduct electricity. It is the reciprocal of specific resistance. As we are seeing that conductance is the reciprocal of resistance, here in the case of specific conductance, it is the reciprocal of specific resistance. So conductance means the flow of current through the liquid conductor. If L is the distance and A is the cross-sectional area and rho is the specific resistance, then that can be given as the formula R is equal to L by A into rho. Okay, here the specific conductance is kappa with the symbol K like symbol. Kappa is equal to the reciprocal of resistance, that is rho 1 by rho. Okay, or we can say the specific conductance is equal to the conductance into cell constant. Cell constant you may be knowing, that is L by A. The conductance is the reciprocal of resistance, that is 1 by rho. So likewise also from the above equation we come to know that L by A is characteristic of the cell used to measure the conductance. This characteristic constant of the cell is called the cell constant. So for measuring the specific conductance, we have to have the unit of Siemens meter inverse. Okay, so the specific conductance has the unit of Siemens meter inverse. Next, I would like to explain an important thing, that is variation of molar conductance with dilution. So by the behavior or by the property or by the process of dilution, how the molar conductance changes. The molar conductance varies with dilution. Definitely there will be a change in the during the process of dilution. What is dilution? Dilution means increasing the amount of the solvent. For a strong electrolyte, the variation of molar conductance, capital lambda m, with C approaches a limiting value when C to up to the value of 0. The conductance is called conductance at 0 concentration. Capital lambda m at 0, or it may be termed as infinite dilution. So equivalent and molar conductance increases with the dilution. Okay, so that is the main point what I would like to conclude with this variation of molar conductance. Molar conductance increases with the dilution. Okay, and equivalent conductance also increases with the dilution. This is very important. We could see in different kinds of examinations this question. The specific conductivity decreases on dilution. Okay, how it is? Upon dilution, the concentration of the solution, entire solution, decreases. When the concentration approaches 0, the molar conductivity of the solution is known as limiting molar conductivity. Okay, that is the point here we should know. Okay, so we have seen some of the points of electrochemistry. If possible, we will see the remaining things in the next presentation. So in this we have seen several concepts. I would like to revise the concept. What is at first we have seen what is electrochemistry and how it is related with different points of charges, and next we have discussed what is conductance and how can it be defined, and next we have seen what is cell constant, and next we discussed what is equivalent conductance, and next we discussed what is molar conductance and specific conductance also, and at last we have discussed what is variation of molar conductance with dilution, and we will be discussing other topics in the next presentation. Thank you.